Okay, so we're going to try and apply all of this in a few different problems today. Let's have a look at the example 17. All right, so a triangle has vertices at A, B, and C. Mark those coordinates. So what I'm going to do is mark those coordinates on this number plane. So A is 1 and minus 3, so let's label A there. All right, so let's just mark it. All right. It says a triangle has those vertices. Girls, so what do I got to do with those points? Join them to make a triangle. So I'm going to try my best to join these up as accurately as I can. All right. Okay. Now, let's have a look at the question. Question part I. Find the coordinates of the midpoint P of AB. So girls, we've got to find the midpoint of AB. Let's just say, it looks like to me it's here, but let's check it out. So we've got to find P there. Girls, remember capital M stands for midpoint. Let's find the midpoint of AB.
It's 1 and 3. Yeah, I figured it out.
Okay, yeah. Girls, like I said, yeah. Instead of using the formula, girls, basically get the x coordinates, add them and divide by 2. So I'll still write the working out just to demonstrate. And get the y coordinates and then add them and then divide by 2. So minus 3.
It's 1 and 3.
But that's 2. Okay, and that's 0. Okay, so that's the midpoint. Okay, so our diagram was close. It's meant to be here. Okay, so it looks like I'll just redraw the diagram. That's my midpoint P. Listening. All right, let's look at part II. Girls, show that PQ is parallel to AC. Let's do that part first. All right, girls, we learned from last lesson, if it's parallel, we need to prove that the two gradients are the same. So let's have a look at the gradient for PQ. So PQ, oh, we don't even know what Q is. Oh, sorry, I forgot to do part I, the second part of part I. It also says to find, it also says to find Q. Girls, Q is the midpoint of what? What does it say? BC. All right, so let's assume it's there. All right, let's do the same thing. Doesn't matter which order. Let's take the two x coordinates, that one and that one, add them up. 3 minus 3 over 2, that's obviously 0, but for the working out. And girls, for the second ones, y coordinates 1 and 3, so 1 plus 3 over 2. So that is 0 and 2. And looks like my diagram is relatively accurate. It's meant to be right there. Let's say that's, what's that called again? Q. All right. Okay. Girls, now for the second question. Let's find the gradient of PQ. So they want us to find the gradient of this line PQ right there. Okay. We know the coordinate of Q, 0 and 2. And the coordinate of P, 2 and 0. All right, girls, let's find the gradient PQ. All right. Girls, when it comes to finding the gradient, you actually want to label the coordinates, x1, y1, because it is important you get the...
y2.
Oh, sorry, thank you. Yep, x2, y2. All right, let's follow that. Girls, remember, we're using this formula now.
Yeah.
y2 minus y1?
0.
0 minus 2?
Minus 2.
Yeah, and x2 minus x1?
2 minus 2.
Yep, so girls, if you simplify that,
It's 1 minus 1.
minus 1. Yep. Now I want to do the same thing for AC. Let's find the gradient of AC. So I'm going to join that up in black. Where's AC? All right, that. Yeah. So girls, can you see by the diagram these two lines are clearly parallel to each other?
Yes.
We're going to prove that. So once again, let's label x1, y1 and so x1, y1, x2, y2. Come on, stay with me. That's minus 1. So as you can see, because the two gradients are the same, the two lines are parallel to each other. So therefore, PQ is parallel to AC. We also have to prove, I'll do it up here. What does it say? We also need to prove, in that same question, PQ is equal to half of AC. Girls, what does that mean? That means they want you to find the distance PQ. So, yeah, the same line here.
How do we do that?
Let's find that distance. Listening. Alright. Distance of PQ. I'm going to write it like that. Alright, girls, let's sub in the formula. Girls, alright, so let's follow these rules, letters again. So we got x2 minus x1. That's 2 minus 0. And then I got y2 minus y1. Okay? Yeah, what square number goes into 8? Yeah, and then root 4 is broken down to 2. Okay? Alright, girls, we've done that side. Now let's have a look at this side. Let's find the distance of AC this time. Okay, same thing, same formula, just different coordinates. AC. We're looking at this, and we're looking at that. Alright, we've already labeled x2 and the rest, so let's follow the formula. x2 minus x1, well, that's 1 minus minus 3.
Which is 4.
Yeah, we'll evaluate later. And got y2 minus y1, that's minus 3 minus 1. What's that? And girls, as you can clearly see, yeah, this 2 root 2 is half of 4 root 2. So we've proven that. Okay?